Hi students, I wanted to make a quick video to discuss with you some concepts from section 11.1. 11.1 discusses theoretical and empirical probabilities. So generally speaking, you all know I like to kind of define things that make more sense and don't necessarily define them using the technical terms. So theoretical probability basically is what should happen in theory. It's based on the possible outcomes of an event, and empirical probability, on the other hand, is what actually happens. If we conduct an experiment, what actually happened, and it's determined by the relative frequency, which simply means just adding up the favorable outcomes of the event that you're looking for, and dividing it by the total possibilities. So the probability of an event in your textbook, they denoted by using P of E. The probability of an event is going to be the number of favorable outcomes of what we're looking for divided by the total outcomes. Okay, so let's look at a few examples. So this is from your textbook. It's number 19 in section 11.1. And in a given week, a veterinarian treated the following animals: dog, cat, bird, rabbit. Determine the empirical probability that the next animal she treats is, and we'll look at part a dog. So for part A, we are trying to determine the probability of a dog being treated. So all we have to do is find that from the table the number of dogs and divide it by the total number of animals. All right. So if we look at our table, we see that there were 45 dogs. So the probability of the next animal being treated as a dog is going to be 45 divided by, and now we need to find the total number of all the animals, so we need to add up how many animals were treated. So 45 plus 40 plus 15 plus 5, and that's going to give us the probability of a dog being treated. So it would be 45 divided by, what is that? 45 plus 40 is 85 plus 20 is 105. Let me get a calculator and make sure I added that correctly and didn't miss anything. Yep, 105. Okay, so 45 divided by 105. Now, a couple of things. It depends on how they want you to input your answer. We can write this as a fraction, so we could keep it as the probability of a dog and then simplify the 45 over 105, and we would get 3/7. Okay? And you can leave it like that. And then as you progress throughout this chapter, you'll see that they tell you, okay, well, instead of writing it as a fraction, sometimes you can express it using your decimals and so forth and so on. But anyway, we'll leave it as a fraction. And might as well talk about the probability of a cat before we move on. So let me see if I can just duplicate this slide. All right, and now I've duplicated the slide. Let's go ahead and talk about, instead of a dog this time, let's do B. Okay, let me go in and erase what I had here for the dog. Okay, alrighty, we are cooking with some grease, as my grandma used to say. And let us do the next example. Okay, so now we want to talk about the probability of a cat. So the probability of a cat would be found by the number of cats that were treated divided by the total number of animals. Okay, so the probability of a cat would be 40. And we remember from our last problem, when we added up all the animals, it was 105. But I'll go ahead and write it just so when you're looking at this and taking notes, you'll know where we got the number in the denominator from. Okay? So the probability of a cat is 40 divided by 105. And we can simplify that fraction. I'm simplifying these by putting them in my calculator. And we get 8 over 21. All right. Now let's talk about some other common types of probability problems that you'll see in your textbook. And then I will post another video from the Pearson publishers that describe some more information from this section. Okay, so now we have what we describe as a standard deck of cards. And if you notice in a standard deck of cards, the cards go from 2 to 10 for each suit, and then there are what we call face cards that are the jack, queen, king, and aces for each suit in the deck. There are 2 red suits and 2 black suits, and the names of their suits are diamonds, hearts, spades, and clubs. Okay, so we'll need this information to help us in answering the next set of problems. We want to find the probability of, let's do number 25. And again, this is from a standard deck of cards. The probability of selecting a 5 from a standard deck of cards. Okay, so I'm going to go back to our other screen and let's look. If we're looking at this screen, how many 5s do we see in our deck? There's a 5 of diamonds, a 5 of hearts, a 5 of spades, a 5 of clubs. So the probability of selecting a 5 would be determined by the number of 5s in our deck divided by the total number of cards. Okay, so the probability of selecting a 5 is, again, we saw that there were 4 5s because there was a 5 of hearts, 5 of diamonds, 5 of spades, 5 of clubs. So that's 4 out of, and then our total number of cards in the deck. So in a standard deck of cards, there are 52 cards. Okay, and I'll go back and write that on this other page. There are 52 cards in a standard deck. There are 4 cards, 4 suits, 13 cards each. So there are 13 diamonds, 13 hearts, 13 spades, 13 clubs. So altogether there are 52 cards total. Okay? All right, so let's go back to the example we were just looking at. So the probability of selecting a 5 would be 4 out of 52. And we can simplify this fraction, and it would be 1/13. Okay? Alrighty. Like we have time, let's do another one. Let's look at number 29. 29 says the probability of selecting a black card. So the probability of a black card. If we go back to our picture before, we see that there were 13 black spades, 13 black clubs. So altogether, for the number of black cards, there would be 13 plus 13, which is 26. So let's go back. 13 plus 13, and altogether there were 52 cards. So there are 26 black cards in total. Oh gosh, what's going on with my Screencast-O-Matic? I don't even know if it's still recording, everybody. Divided by 52. So the answer is 1/2. I'm going to pause this video, make sure everything is recording, and then I'll make a part 2 because I just got an error message from Screencast-O-Matic. So stay tuned. Hopefully this has recorded. I'll be back.